Assalamualaikum and greetings to everyone. Today our group will present for the group assignment for the MAT183 Calculus 1, and that is application of differentiation. Here are the group members. The leader of the group members are Awan Najib Farhan bin Awang Alim, and the rest of the group members are Aizam Mukmin bin Shaharuddin, Danish Fahmi bin Bahrin, and Anderson Giggs Anas Umar. Today I will present about differentiation. What is application of differentiation? Differentiation can help us solve many types of real-world problems. We use the derivative to determine the maximum and minimum values of particular functions. What is maximum and minimum problem? Maximum problem are a maximum point of a function is the highest point on the graph of a function or the point that takes on the largest y value. The minimum problem are the minimum point of a function is the lowest point on the graph of a function or the point that takes on the smallest y value. And last but not least are the importance of maximum and minimum in real life and in calculus. For in real life, we usually use to maximize the profit in the company or minimize the cost to make the particular object. As for in calculus, we use to calculate the highest and lowest point of the curve in a graph or to know its turning point.
Next, for the application for maximum and minimum problems. The maximum and minimum problems are also known as optimization problems, are also known word problems that ask for the maximum or minimum values of a function, often according to a certain constraint. To do the maximum and minimum problems, you should always, and first and foremost, you should always draw and label the diagram. Secondly, you should find the formula. Thirdly, you should use the first derivative and the second derivative. And last but not least, you should always substitute the answer. So for the problem statement, we chose a question about two chickens. A farmer wants to build a rectangular fence that will enclose 120 square feet of area for a couple chickens. Two opposite sides are to be made of wood at a cost of 20 ringgit per foot. The other two sides are to be made of wire at a cost of 25 ringgit per foot. What are the dimensions of the fence that will cost him the least to make? Assume that each side of the fence must be at least 3 feet. So from the question, we should know that the area of the fence is 120 square feet, and the cost to make the two opposite sides made out of wood is 20 ringgit per foot, while to make the other side using the wire, it is costing for 25 ringgit per foot. And based on the last sentence, we should know that this is a minimum situation, because from the last sentence it said that what are the dimensions of the fence that will cost him the least to make. So the word least highlights the point that we are going to use minimum for this problem.
Now for the second step is we're creating a formula to find the function that we will want to use for the maximum and minimum function. Now since we have two sides of wood fence and wire fence, the total length of wood fence we use is to x, and for the wire fence will be to y. Let's call the width for the x costs 20 ringgit, and the height for the y is cost 25 ringgit. So the function will be like 20 times by 2x plus 25 times by 2y. So the final function we have will be 40x plus 50y. So moving on to step 3, which is finding the first derivative. We already given the value of the area, which is 120 equals to xy. So we need to find the y value. To find the y value, we rearrange the equation to be y equal to 120 over x. Then we substitute that equation into 40x plus 50y. So we will get 40x plus 50 times by 120 over x. So the final function will be 40x plus 6000x, which is a very big number. Then we will perform the first derivative. Our first derivative will be 40 minus 6000 over x squared. From here we know that our domain must not less than 3 because it says at least 3 feet and below 40. And then we let the differentiation or the total of that equation to be equal to 0, so that we want to know the value of x. 40 minus by 6000 over x squared equal to 0. After that we will get 6000 minus x squared equal to 40, and then after that we will get 6000 equal to 40 times by x squared, and then last but not least we will get 6000 over 40 equal to x squared. Now insert that value into the calculator. We will get x squared equal to 150, and then we find the square root of it. It will be equal to 12.25 after it has been run off. Thus it is actually plus minus 12.25, but we can eliminate the negative one since we cannot have a negative length. So we will have 12.25 as our one critical point.
Step 4, for second derivative, we use this for find whether this function is maximum or minimum. So the calculation is in the whiteboard. Cx equal to 12000 over x. Cx equal to 12000 divided by 12.25 power 3 equal to 6.528. So when we convert it into RM ringgit, it will become RM 6.5 cent. Since it is more than 0, it is proof that x equal to 12.25 is at the minimum. So to find the y, we will substitute value in x 12.25 into the area formula. 120 equal to xy. Substitute x into the function. 100 equal to 12.25 times y. Y equal to 120 divided by 12.25 equal to 9.79. So therefore, we can conclude that x equal to 12.25 and y equal to 9.79. To answer the final question, we will get the dimension of the fence with minimum value equal to 12.25 times 9.79. So for the conclusion for our topic, application of derivative, by applying the differentiation method in this situation, we can conclude that the application of differentiation can be used to minimize costs, finding minimum dimension, and solve problem related to area. That's the end of our presentation. So thank you for listening and good night.